understand what's the best design for what we want to capture is probably like 1 week of studying the problem. Then we say we're pretty convinced that the best way to implement this is to put the measures and we implement it.
Can you also
time series, it's important to be extremely memory efficient, so probably the other time series is one dimension. Actually, the problem with sorted sets with time series is that they are probably in some ways an overkill because they have additional metadata. Let's check, but for sure, between indexes and time series, there is new use cases for Redis which are very important and both are actively explored by the user base because people are doing this stuff a lot. But if we give direct tools to solve people problems, it's not a better idea.
So before I start, I just wanted to say something about Lua. Itamar showed he implemented some tree solution in Lua. And I got the name, but you were talking in your last slide about finding better ways to manage scripts and reuse scripts. And I don't think we addressed that enough. I don't really have any solutions, but ideally, we'd like for some sort of Lua script ecosystem to develop in the community, I think. So a solution like trees or any other functionality someone develops can be reused easily in search. So it's something to think about in general. Okay, this is something we did talk about, I think, a bit last year, about the source base. I think with your work on this view, it emphasized it a bit more. Sentinel also, how source can be shared. I'm from Redis Labs, by the way, and so in Redis Labs, we use Redis source for more things because we manage such a massive Redis service. We have to do things, analyze our RDB files, maybe sniff Redis protocol stream and see what happens. So there are all these things we do, and we kind of copy code from Redis or modify Redis in all sorts of ways. But the situation today, I don't think is ideal. I want to talk a bit about some thoughts we had. So basically, I want to show how the Redis source is organized from my perspective, and we'll on to the work with me on this. So basically, Redis source code, we have this under the source folder, we have all these files, server.c, replication.c, networking, all of that, which is like the heart of Redis. And then around that, we have all these different modules, like all the data structures, SDS, dictionary, the I/O abstraction, event loops. We have all of this, and this is organized pretty nicely because the source can be reused. It's sometimes not clear what's part of the heart and what's a reusable component because it's all flat in the source folder, but it's still organized nicely. Then we have some parts that ideally, from my perspective, could be more abstracted as a library outside of the main part of Redis, like everything related to RDB file processing. But today it's too intermingled with the main source code. You can't just take the RDB that's .c and then use it somewhere as a library. Again, for the Redis protocol parsing, the command table, which can be very useful in other applications, like if you're developing a proxy, you want all the commands with the flags. You can pull them out easily from Redis. So there are all these things that I think could be external modules, but they're currently tied into too much with the Redis source. And then we have the binaries, like Redis server that uses everything, or CLI that uses some things. Sentinel, which is basically Redis server, but some things aren't used. So it's kind of a mix, the binaries. And I think in an ideal situation, the binaries would just be something that uses the external modules and then add their own functionality and not be too intermingled. So I don't have like a perfect solution here, but ideally, I would think this is an easy situation to do that. For us, it's very difficult to extend Redis or use Redis source the way it's organized. So I think here I tried to list the way I'd like things to be. So everything related to RDB reading and writing, if it could be externalized as a library, that would be ideal. In our fork of Redis, RDB parsing is already a totally different function, which is what we're doing is like SAX-based parsing, where we get callbacks called per object when reading the stream, and then when we get like a callback of a new key or value, then we can add it to the DB structure while reading an RDB, but we can do other things. We can filter while reading the keys, not load everything to RAM. We could, I don't know, transfer it over the network. We could do different things, but it's still, so we rewrote the RDB reading code and extended all of that, but it's still too much tied into the main Redis source. For example, there's references to the global server object inside the RDB parsing code, which is a problem. Protocol parsing is the same issue. Is like Sentinel and Redis server, and I think this to an extent, are basically they have this generic. They all receive client connections and parse Redis product on the commands. So it might be smart thinking of like a Redis multi-client execution thing that can be used in different projects. Like the main event would be externalized. And that's also true if we go with the multi-threaded I/O approach. All of that could be library, multi-threaded I/O, Redis protocol processing that can be used in different projects, not tied into the internal logic. It's something that it's basically impossible. Anything that uses that structure, we can't run threads over that. We can't. It's also just generally bad design. They have global variables. So, and this is just something that can be fixed. Maybe you have some ideas about performance implications of that, but it's something that we worth considering. In High Redis is a bit of a weird. The Redis project uses High Redis, but there's another High Redis version on GitHub. That's because the CLI, the Redis CLI uses High Redis, but it's part of the Redis project. High Redis uses SDS, but there's the SDS of the Redis project. So another thought might be,
Finally, I believe that with all we finally were able to unify all the SDS versions.
yeah,
Standalone, Redis and high Redis, right? Jerry?
We did that Redis itself should be defined. Just the Redis project itself is not big. So Redis, it all uses the new.
The new and the Redis is going to use it in the future as well.
Probably, yeah.
So it's like around should be pretty much backward compatible. So and because in the Redis copy I had in my tree, I substituted the new SDS and everything works. So basically, it's a change that doesn't need any fix in the code using SDS because the API is the same. And Redis, I think, is a slightly older version, but it's basically one of the. I just copied one of the old versions of Redis inside the tree. The problem is with Redis, if we basically, even if Redis is not modified compared to the one that is shipped by January, I cannot basically use a sub-module or something like that, because otherwise one change made to Redis can impact the stability of Redis. So what I try to do is to run unmodified versions that I upgrade from time to time in major releases, so that there is some time for testing. But I believe that Redis and SDS are basically at this point fixed because they really diverge at some point. So now at least this line should be fine.
I think it's better now, but maybe a way of thinking of it is that if Redis uses some of the same source that Redis uses, and because Redis CLI uses Redis, and Redis CLI is part of the Redis source, not part of some external project, which is also, but it might be worth just considering kind of canceling the official Redis and moving Redis development into the main Redis source, and then
that will be horrible because I am at the single point of failure of everything I touch. So if Janik is able to merge patches, do improvements, it's because the project was separated back then. Imagine if I had to process requests for Redis, they could be there for 2
you
years.
can make him a Redis committer, and if he ever touches any other piece of the source, just kill him. But okay.
So in the end, it actually should be like, if I finally get a run updated, it will be like the same version. It's just that it's synchronized back to Redis from time to time. So I actually think it's part of what you propose when you get that done.
Exactly, it's an independent repository, but I synchronize it with Redis from time to time, making sure not changing my local implementation. As I did it in the past in order to make sure to fix things and stuff like that.
Someone will give you that.
Sorry?
You use each submodules.
Yeah,
let's take it.
Submodules means that I have always the latest version of everything.
No.
Submodule is frozen to commit.
But then what's the advantage compared to CPU?
Well, you just know that it's there and you can update it whenever branch you want automatically. You just select branches and that's it.
We don't have really it's not just that we have issues copying, removing, I do it and stuff. It's more a problem of how much stable this version is compared to Redis. It's not a source management problem. It's much more a problem of two projects that are tightly coupled, but with differences, and one can impact the stability of the other. So the current model, I think that finally we find a good setup. One, because Jean-Luc fortunately takes the maintainership of the project that was otherwise unmaintained. So the project is starting to evolve finally. And then I can backport it from time to time. Just this, I think it's going to be solved like that. So the important thing is that when one wants to start a new project, to get from his repository and not copy from the Redis repository, otherwise it's an old version.
Yeah, I think.
And the problem is if we follow suggested modularizing some parts of Redis, making it like the RDB parts or the protocol parsing code, standalone module, then if a third party needs to use high Redis and those modules and both have things like SDS dependencies in the back and they are not compatible, then we run into conflict.
Yeah, so what we should make sure, but we already basically are doing this, is that all the versions of everything use the latest SDS from the standalone repository. Now we have a standalone repository for SDS and Redis, and everything else copies basically from this standalone repository. At this point, basically what we should do is, for example, if Oren has new improvements for SDS, should make the pull request in the SDS repository. I manage there and I then copy the new version in Redis, and it's also upstreamed to Redis and everything else.
A lot of other, I'm not familiar with the source code of Redis, but very good, but there are a lot of other common source code, I guess, between the two. AE, I think, and maybe some constants. And so if we look at, I'm not sure how to do the whole list, but in the next slide. It's not listed here, but there are other than common defines, common source files, except for SDS. AE is there, right?
Yeah, there is
Or at least
ANET, and there is, yeah, there are multiple, but
I consider, I don't want, or don't consider SDS to be the only Redis reusable component. Dict.c is a Redis reusable component. Maybe some constants or enums from the Redis header are Redis reusable components. What we are suggesting here, you all didn't get to talk about it, so maybe we let him finish it.
Maybe I can describe in our project what we do. Like this approach is we compile or we link Redis as a library, and then just without the main function basically, and then we can use it in other places. But if we link with that and high Redis, then all hell breaks loose because
I was taking Redis as an example. Every item you suggest in your previous slide requires basically a different discussion. I am worried that the first two items impact performance in a very serious way. But the network parsing and the RDP library, if made as libraries, I believe they impact performances a lot because both are very critical paths, and there is a reference to this global state because they do this in a very fast way. So extrapolating this requires callbacks, requires the fact that the loading of the object cannot modify directly in data structures check for so every function that starts in something where you pass a lot of arguments because it must be general. Okay, so I believe that there is a bit of a tension between the making this truly modular for certain things. I mean, also the protocol parsing. The protocol parsing does all the strange things of gluing objects or reusing the old client argument vector object to write inside it. I'm not sure if you remember, there are things like that. Like, okay, I'm reading this argument, but maybe the current command argument vector has already room in this space for this, so I call read directly using the SDS already. We have all these optimizations are done if we done it as in the library. And also Redis protocol parsing is trivial, so it's a shame to extrapolate it because it's so easy to implement. Moreover, Redis implements Redis protocol parsing, but maybe you don't really think when you write protocol parsing more than just the parsing of the protocol. And indeed, you write at some point generis Redis protocol command server, and that's it's shared between this queue, Redis Labs internal products. So there are many users of this. I believe that this could be in some way captured, and then when there is a problem about development speed, what I mean is, if I want to make a change to this, if I put it in a different repository, we make sure that when I do one change there, I don't break everything else or stuff like that. And but of this list, the most clear win I see is the part that implements the server as something that's networked and is able to accept clients' commands.
What we do a lot is the RDB parsing. When reading the RDB from disk, or from network even, like with the diskless replication on time, then your IO band anyway. There's no critical performance the global server variable from the RDB parser. Doesn't offer that much of an advantage, and there are a million of other applications you can use RDB reading at least for, like merging multiple RDBs. There you like writing also.
For RDB parsing, you mean the code that loads Redis dataset inside Redis, right?
Oh, yes, but you can split it into some code that passes the RDB and generates an out with the value, and split it from the code that puts the value in the dictionary. This is what we did. We have the parser that creates the object, and then it calls a SAX style callback. And we have many implementations of the SAX callbacks. So many users of the RDB parser. One of them is Redis, which puts the values into the dictionary. Another one.
And you saw no regression in performances in loading times.
I didn't say.
You see no speed regressions with this approach.
No.
If it's as fast as the current approach, then it's only good if we refactor it outside. I'm all for this as long as it doesn't make the code slower to load and second and save the.
And then you don't need, for the first part of RDB parsing, you don't need the server stuff anyway. Maybe just one flag if compression should be enabled or not, something like that. You can pass that argument. But all the client and the database structures are not accessed because it's a library. We're creating a librd, like RDB tools we have in Python, which is outdated, very slow in Python.
So you basically
so far, I think there's always trade between good design and performance. And I think one of the good things about the current state of Redis is that it's really well balanced. There's no real trade-off. It doesn't trade off the performance for good design. It also doesn't trade off the good design to get performance. It's really a balance.
If you identify a right place where to split the internals of Redis from RDB parsing so that you are seeing no regression in performances, then I'm all to merge this work because this would allow me to also avoid to have a second implementation of RDB passing for the RDB check tools. And now in Unstable, the RDB check tool was Redis itself. I don't know if you noticed the change, because when there is a file that's corrupted, Redis automatically starts the check. Instead of getting the bug report, it's corrupted, Redis runs the check and put it in the report. So that would be a big advantage.
So what we are doing, one of the things we're doing, creating a librdb SO file, libredis SO file, which has many, maybe the command table and maybe some, you have discussed the requirement for a proxy to be aware of the command table flags. You can pack a libredis SO file and use it inside your various executables, maybe RDB checker and maybe something else. And then if that executable also needs to use high Redis, to use libredis and high Redis, you have two SDS and AE O files inside your executable. We can try to use in sync, but it's a bad thing. And
so for now, where you put this command in the libredis, you put AE and
what we do today is we build Redis and then we extract the main function out of the and we just link it as a I don't even remember if it's a static or shared object, but that's what we do, and then we can use it for anything. But that breaks when we use the high Redis.
I think that the problem has two phases.
But that obviously isn't ideal. Building Redis and then.
But so right now the problem has two phases. One is the modularity of the design of Redis. And what you are doing is to make it more modular, like extracting the RDB, and we can extract more pieces. For example, we can extract the part that implements the server in a self-contained file and stuff like that. Another problem is the distribution of this file. To have a central source of truth for the code.
Right.
But this problem is, in my opinion, less of an issue. I think we will figure out, we can say certain things, for other things, there is the repository, that is also true. Making it more modular is the critical step.
Right.
And if it's possible, there is only to gain, because we can.
This is like just a draft. Imagine it as a directory structure instead of just having a source folder under Redis, where you, by putting all these source files under modules you already defined, they can be used outside of it. They have no dependency on the server code. This is the case for many things like SDS. And then putting server code on directory. And so then just having these two different directories in the source tree already helps you understand what's part of Redis and what's outside of that. Sometimes it's difficult to understand the difference between I don't know, t-list or t-hash and dict or addlist or something like that. But they're really different. This is an implementation of Redis command, and this is just a reusable data structure.
Yeah.
So just thinking this way, maybe structuring the directories like that could help. The idea here was to theoretically be linked into some libredis, or the Redis or this RDB, and then that would be reused. But these are all thoughts.
Also, in this case, notice that high Redis is, if split this way, it can use, it's not in depth anymore, and it can use directory. So even if we keep Jean-Eric's repository separate from yours, maybe we can put there modules and high Redis, which is reflecting the modules and high Redis you have here.
Yeah, probably I could use a different directory for when Redis is the source of truth, and for things that we just copy from an external repository. So Redis is more logically under depths, maybe, because it's our dependency. But maybe if high Redis itself puts common things into a separated directory, like AE, SDS, Redis itself modularize this in a separate directory, we can just put a symbolic link or something like that in the common parts, so that we have it inside depths, but actually it uses our common links inside modules or something like that.
I don't see how Redis as a depth. It's not like Lua, which is a dependency. It's one of the products. It's like Redis CLI.
Dependency. It's not quite part.
Maybe the solution here is to extract Redis CLI and tests and kick them out.
But if the user just
Then high Redis stops to be a dependency.
But high Redis is still used internally for all the client activity.
For what?
Between
Exactly. It is a dependency.
Okay, I was not aware of that.
Basically, everything I don't under depths. There is everything we have no control upon as a Redis repository project. So everything is in the depths. We just trust the authors. It's just a side effect that I am among the few contributors of Redis, like the tools and a match to Gmalloc or Lua. But it's external components that they can use.
Sentinel really using high Redis, or it's using some parts?
It's totally using Redis to communicate with other instances.
sorry, go on.
Please.
You said that SGS, the most up-to-date SGS is in Redis at the moment, like from your separate repository, is that right?
Yeah.
And there's no patching needed for any of like Zmount or anything like that?
No, for now, I created a few defines that you include in a separate either file where you can define what is the allocator. So finally, we completely made it compatible with Redis and external. Okay, but it's we basically all understand it's a complex problem,
But there are some things that are already actionable, like the Redis.
Exactly. The only thing to fix something like that is to make incremental progress.
There's some major refactoring involved some parts that you
If we want to
take out the
create
command server loop.
But for example, for me,
When you do that, one of my main concerns is mergeability with forks. If you have a fork of Redis and you're doing some change, and I did tons of changes, when I try to merge your changes, I'm in great pain. And if we modularize everything a lot, it will reduce the pain in merging. The first merge will be even more painful because refactoring. Factoring is something that damages a lot.
Another problem I have currently is that a given data structure doesn't carry with it the implementation of everything. For example, in the file t-list.c, I would like to have directly inside, and this is unfortunately against the modularization in this way. It's another kind of modularization. But what is the most useful? For example, when I remove the Redis objects from data structure implementations, I changed it, for example, t_set.c. But then the implementation of how t.set of how sets are created in the RDB were in the RDB, so I had to jump in the RDB and change the other parts that belong to the data structure in another file. And then in AOF.c, because the data structure was also rewritten in the AOF, so I had to create the comments. So one thing I said is, would be great if data structure would be represented inside a single file with everything is about this data structure. But in this way, we segment in a different way compared to these needs. So also in the way we want to modularize, there are tensions if we want to get certain advantages. It was really terrible to jump between multiple files, trying to find pieces of a data structure around the Redis source code. And certain pieces were very far compared to where you would expect them to be. But we can try it, at least.
So it's always another point of view because it was architected the other way around. One file with all the set implementation for AOF, for RDB, for things, another file for hash, again, AOF file. And then you want to change something with the AOF, then you have to go for the files or the data types.
Yeah.
So it's
it depends on the
point of view.
Exactly.
Yeah. And sometimes there's no clear benefit. Either way, it doesn't really make a difference. And sometimes there's real benefit in making changes.
Yeah.
The way everything is broken down.
Probably we instead of trying to achieve beauty of the source code, it's better to stress reusability. So it makes sense to actually isolate a given functionality inside a file.
It's very subjective.
No, but you said it yourself about a concern about application, but see that it grows and becomes unmaintainable. So breaking into modules is something that will allow you to grow. Maybe split the RDB parsing into 3 stages and put each one in a different C file. Serialization and deserialization, encoding and de-encoding of the raw serialized data into the encoding we keep in the RAM, and then the part that actually adds them, or part of, in other words, the dictionary. So it's actually 3 stages, and each one is contained in a file. And you can, if you want to use just the encoding, just serialization, you can.
But I'm starting to have the same problems you have. I'm starting to have with this because, for example, now that I changed so many things because of the lazy-free stuff, for example, the disk queue output buffers are no longer in sync with Redis ones. So it's really worth to extract. Or even another thing, for example, there is you want to create a database and you want to use the Redis protocol because it's already well understood, it's easy. And then maybe if we modularize more, we just extract 2 files and you have a network server with just a bare minimum in order to accept command and dispatch, even if dispatching does nothing. Initially, it just says command not found or something like that. Yeah, so there are many things to consider, but the important thing is that to make this is a huge effort from the point of view of time of development spend, that when I was basically alone developing Redis, it was not affordable for me, it was much better to improve Redis. Because for Redis labs, to don't have this modularity, it means anyway to do more work. It's the right moment that we can make something about that, because it's functional to do less work in the future, to do this work now, so we end with a better Redis, with an easy time to merge and stuff like that. So if we can start, I can try to make things.
Yeah, and hopefully more projects like the Python, RDB tools, which is already completely out of date. So more projects can benefit from pulling stuff out of Redis. In the case of RDB parsing, it's ideal if there would be really a library which people can use, because Redis RDB tools is used a lot in the Python and RDB parser. It's both slow and outdated, and pull requests aren't getting, it's not being maintained that much. And it's a shame that someone had to implement it once. So.
Yeah, and also we have already doing validation, one for checking and one for logging them. That's really that. Yes.
Small one.
Then we better to talk at the end at this point. All the ideas.
Just a time check, guys. So it's 3:15. We have about 45 minutes left before we have to go.
This is
But
Okay.
then we have to leave the room.
Yeah, so there's going to be another event here at 5.
Okay.
So they're going to get here at about
But the
4:30.
thing is
So.
that we can start to continue to talk everywhere, like the street.
Yeah, so also, if you guys want after this, there's a place called the Flying Lion, which is about 4 blocks away. I can give you the address if you want to go have a beer. And then tomorrow, I'll also shoot everyone that registered on Eventbrite, or I'll put up on the screen to where we're going to have the unconference. So it's going to be a lot more users. It'll be in the evening from about 6 to 8:30. And we'll have a few drinks there and snacks and what have you. And please don't run out once he's done, because I do have a survey for you guys. I'll send you the link. It's 2 questions. Yeah.
okay. So I'm with Redis Labs. We talked about it, but we wanted to present it to the other audience to fit. Because we are selling to enterprise customers, we hear a lot about the need to have master application in separate. But usually when we start asking the customer, how do you do conflict resolution? First of all, they don't understand the question. What is conflict resolution? Secondly, they treat it like, okay, you should be with that. And what we found lately is that not most of them, but let's say 30 or 40% of them, for their use case, not really needs them. So the use case is like this. Think about a Redis deployment. It could be a simple deployment or a cluster deployment in one data center, another in another data center, the same data set. But the user of the application can never write to both at the same time. And this is the application responsibility. This is not Redis responsibility. So the solutions that we wanted to talk about is a way to make it master application without conflict resolution. It's a bit strange. It can create a lot of problems. But on the other end, the benefits of that is that whenever the user moves from one location to another, it still has the locality. Okay? It still feels like everything is local. Again, no conflict resolution. So the use case is single data set. User never writes twice to the same, twice in different locations to the same data set. Sorry. Gets the locality, and the use cases that we see is gaming, geo application like Groupon or similar stuff. The things that we should take into account is to avoid loops. There could be situations where the data is totally inconsistent. Think about misuse of this architecture when you at once write in 2 different locations to the same value, to the same variable, different values. Okay? So you have A, someone writes 3 here, someone writes 4 here. You just switch the values, and because you don't replicate it again, you have inconsistent database for it. Okay, so it could be a situation like this. And of course, there is a market perception regarding that, because people, sure, the competitor, which some of them do exactly that, by the way, Couchbase multi-site application is exactly that. But because it is, we are open, we are community, we are telling everyone the limitations, it could create bad impression of Redis. So that was the situation. We spoke about it internally. I would like to see if any one of you have some use case or heard about it or can see it as something that you can use.
Yeah, sure. I solved this problem by having a master data center and 2 slave data centers. So usually you need the reads faster, the writes you don't mind doing them. I know that's what Facebook are doing with MySQL, for example. So basically what we did is we write always to the US and then in Ireland you just read from slave. It creates a host of other problems. But sure, it can be used.
And in your scenario, there is no way where multiple users will write to the same piece of object in the data sets at once?
Usually no, because most of those stuff like aggregates and buckets of counters, you do them offline in one data center that does the background processing. You're really actually using like the last visitation time to the user or something that's personal to the user. Otherwise, there won't be a reason to write it in real time from 2 places if you desire data.
Bill, what about your situation with this? Your scenario like this?
So I do talk to a lot of people that want this, and a lot of times, that's one of the first questions. Is are you looking for locality or are you looking for consistency? Because it's multi-master, it's almost impossible to have both. Maybe it is impossible. And it always starts out with, well, no, they'll be writing different days. And then they implement it. And then, no, it's not always different data sets. And the particular example I see a lot of is counters. If you look like hit tracking and that kind of stuff, like if you're doing real-time hit tracking of websites and then you can get that rather than set A equals 4 or set A equals 3, you get an increment, and you wind up with getting different values. So I do see, there's a desire for it, but the actual use case that I see most commonly when you start going, okay, well, if you're actually writing different data, then use 2 different instances.
But then when the user
replicate as a slave over, rather than do like a multi-master, do a pair of clusters, and that works for the vast majority of the cases. But where you get to it is somewhat of a little bit different use case for Redis in that. So there have been a few times where I've had a large setup, and I'd like to be able to write some data to my local slave that isn't replicated out. And we can kind of do that now, but if you do like if you lose connections to your master and the precinct, all that data is gone. And that's usually where it boils down to is I want to have the main data and I want to read local slaves. I'm okay with doing remote writes, except for I need to have this data only in this data center. And usually where I see that the most is when you're dealing with multiple countries. And if anybody's read the news lately, it's going to get even worse, where countries are starting to come down much harder on, no, you can't store my user's data in any other country where their origin is. And that's the type of situation where this type of setup is going to become more desirable, because then you can store, you do hit tracking, you can send hit tracking non-user identifiable information to other countries. But the actual user session and that type of stuff will have to stay local. So that mix of having the multiple masters, maybe some of that data is never intended to go on the side of that data, and that's where it will get tricky.
The case here is that, as Dvir mentioned, it's per user information. but you do want this data to be available on other data center in case the user, for some reason, goes to another region. Okay.
Yeah.
And you want to keep the speed. So, you know, we talked about it yesterday. I think the ultimate solution will be a fully conflict solution, which is probably impossible to do, almost. I mean, we have a budget.
Counters are the easiest thing to.
Yeah.
Because simple counters, there's no conflict.
Yeah, I agree.
Do you know how Cassandra does conflict resolution in counters? Do you know how Cassandra does?
What?
They split the counter into a few replicas, and when you implement in one node, it's like 3 separate counters.
Yeah, it's
And when you get the value, you just sum them up.
And I wonder what they do with append, because they don't have append data structures. Because if you think about append, it's almost impossible to do conflict resolution.
You can, if you have, basically what you do, if you have a list, for example, is to attach a vector clock in each list item. It's extremely expensive, but then you can at least merge the different lists for a casual ordering, and it's an approach. Another thing that works in order to merge lists is to attach a timestamp in the list items. When you merge new lists, you find the common longest sequence, and then the other elements remaining are merged according to the timestamp. You go towards head and tail, and you can. I like 3 or 4 years ago wrote a blog post where I said it would be cool to have a version of Redis that is AP, and this would be the way with data structure driven merge functions, so not user defined.
Yeah.
Later, React 2.0 kind of implemented something like that. But for Redis, I documented each data structure, how could be merged in these different scenarios. And then, but now there are many publications about convergent replicated data types and stuff like that. So the problem is that these solutions have a lot of overhead and are very slow in order to process the merge between the two, but it's absolutely needed. What we could do in order to make such a thing viable is to do simpler gossip-based merges. So we let the systems to the sync. For example, the example you made of list append. 2 list appends in the same time in the same list for 2 different sites could create A, B, and B, A. Then basically there is a secondary thread in each master that computes the kind of unique ID of each key, so that if there is a given content, there is this ID. And separate masters gossip about recently changed keys, one to each other. When differences are found, they are merged just in this given moment. They or check count. It's a very stupid merge function, but it's a lot better than leaving data not merged forever. And then, for example, they use the timestamp. If the timestamp is far apart enough, the last write wins. Otherwise, if they are very near, unions are taken, or the list with most elements is taken, or stuff like that.
Yeah.
But it's still was adapted loses rights for sure, but it's an eventually consistent setup. But there is a lot of work to have a very good implementation of this kind of ideas. And at this point, if you have that, you don't want to limit this to just masters being the same copies, but also you want to go Dynamo paper style.
Yeah, it could be. I think what we hear is that users want to feel like everything is local, and behind the scene, do your magic and solve it. This is This is the solution. But there is a need for that because Cassandra is very poor in doing so. And React is even poorest. It is very slow. We met many use cases where it just doesn't work.
Another thing that we could do is the following. We mentioned Redis CP, a consistent Redis that provides multi-master features. What we could have is in such system basically as an asynchronous mode. Normally the system is synchronous, but there are ways to relax Raft in order to lose this linearizability, but still to retain the eventual consistency guarantees to make it synchronous. So Redis CP could absolutely implement this in a way that conflict resolution is not needed at all.
Yeah. Maybe we thought about it, but maybe it can be. Let's assume this is a CP system. It is not complicated. What we thought initially that this is a CP system, this is a CP system. Between them, it's an AD system. But it is not like this is a cluster and these are another legs or node of the cluster. Because then you need to have, the else check mechanism across the nodes of the cluster to understand which node is available and which node is not. And because this can be across one, you can reach to wrong decision because the response time is slow here, but it's very fast here, or things like that.
Yeah.
So we thought about treating it as a totally different, let's say, cluster. Forget about if this cluster is AP or CP, but between them, it's for sure AP. And for all users that we spoke with about this situation, about this configuration, they agree this is fine. I mean, no one really wanted you to wait, this user to wait.
Yeah, absolutely. But if you relax the Raft in this way, you end with the system, basically.
I agree with you, but then the cluster manager that needs to decide which node is available, it is hard for the cluster manager to. I'll give you an example. For instance, Redis Labs cluster has a certain profile to check availability of the nodes on AWS, which is a relatively noisy environment. And therefore, when the node fails, we don't say immediately that the node is failed, because you can have intermediate network speed. And it is very bad to decide that the node fails if it is only intermediate network speed. We add it in the past. So we change a bit the profiles. But when we install it in a private environment, which is relatively clean, the failover time takes too long, so we change the profile. So if you think about this, you should have, it's a complex cluster to manage that way, in general.
Yeah.
Because
there is a solution, perhaps. Think at this setup, and then think there is here a cluster. So the masters, instead of replicating each other, they write to this system that we don't very well identify. And this system is responsible of serializing the stream of comments received and then send them in the masters, detect if there is a violation of order and fix the keys. So the systems remain independent.
Yeah, this is, I think Yuval mentioned that as well. And when you activate the client immediately, you give back to the client, to the user immediately, or after you replicate here. But then you go to a different system that does the consensus.
Exactly. This is, of course, starts to be a bit more complex. But basically, the system, because it has vision of all the rights received by the masters, can detect a violation and perform the operations in order, like, remove this item here, insert the new one, and then re-add and do the fixes. It's a bit complex, but
yeah, good. Okay, we can continue working on it.
So, in the vein of crazy ideas on there, what about the idea of making the master on the right? What if Redis had a proxy mode? We talked about having Redis proxy as the first class citizen. What if that was mode? So we've got servant, we've got master, we've got slave. What if we had a proxy then the master on the right, since the goal here is for DC2 to look like a local version of DC1, rather than deal with consistency, what if the master on the right was in proxy mode and he actually proxied to the master
The problem
on DC1? So everybody in DC2, they're talking what they think is a master.
Yeah, we talked about this yesterday at dinner, but the problem is that the customers that want to this use case usually want to locally read after write consistency. So after they write, they immediately want to read and see the change. So it's a complex set of requirements.
Yeah.
Otherwise, you could have, we say acceptable if you say, like retain the right, just acknowledging the right, but trying